So to get a turning point, first you need to understand that what are turning points. Turning points are the one where f dash x is equal to 0, or dy by dx is equal to 0, or there is one more interpretation that tangent is parallel to x-axis. Have a look at the curve. These are the turning points which are clearly visible. And if you look at the tangents at these turning points, they will always be parallel to x-axis. You need not even show x-axis. It is obvious that x-axis will be horizontal over here. Okay. So these are the meanings of turning point. First, we should be clear with that. F dash x is 0, or dy by dx is 0, or tangent is parallel. Now, how do we find turning point and how do we use it to get points of maxima and minima? Let us see that. So to begin with, we should have y is equal to fx as a function. We will differentiate that function. So f dash x, and then we will equate that with 0. After equating that to 0, we will get an equation. When we solve that, we get x values. These x values are called as stationary points. Stationary points by definition are the one where dy by dx is 0. Stationary means they are not moving. There is no change in dy over dx. There is no change in y over x. So that's why we
So
call them
maximum and
stationary.
minimums are stationary point?
Yeah, it is one of the stationary points. So stationary points are also of 3 types. One will be point of maximum, one will be point of minimum, and the other one is neither of them. There are stationary points like this in the curve, which are not maximum nor minimum, but still the function is stationary over there. So those are called as point of inflection. I'm writing short form, point of inflection. Okay, point
And
of
this is where
inflection.
we equate, right?
Say again.
And this is where we equate
Yeah,
f double dash.
yeah. This is where f double dash x comes into picture. So as of now, we have x values obtained from putting f dash x is equal to 0. Now, where do we use these x values? So for that, we will differentiate the function one more time. So f double dash x is there now. Okay. In f double dash x, you're going to put these x values, and it's just a function in which you are substituting x. It means after substituting x and solving, you're going to get a certain value. That value can be positive, negative, or 0. For putting a x value, if your f double dash x is positive, then that x value is a point of minimum. Only x coordinate of minimum. When they say, find the coordinates of minima or minimum, so you have to put that x value in the function to get corresponding y. If I go back to this, so this is the point of minimum where we have just x value. To get y value, we have to put this x value in the original function. Is that clear?
Yes, miss. I mean, so.
So we will apply the same thing even in the question. Okay. So f double dash x greater than 0 is minimum. F double dash x less than 0. So then that particular x value will be point of maximum. And when it is equal to 0, then we call it as point of inflection. Point of inflections are very less likely to be asked, or they are very less frequently used. So that's why many students don't have much idea about this. Okay, but there is a possibility that f double dash x becomes equal to 0. And as per the graph, this is the possibility. Okay, in almost most of the functions, you may not find these kind of region where function is not changing at all. It is not a point of maxima, not a point of minima, and function is not changing. It is like a flat line. So that flat line visually is point of inflection. And point of inflection is verified by putting the x value in f double dash x, and if it comes out to be 0, then it's a point of inflection. Now we'll apply all these things in that question. So the question was y is equal to x cubed plus 11x x square plus 35x plus 25. So to begin with, we will just find f dash x, 3x square plus 22x plus 35. Second step is f double dash x equal to 0. And then we have to solve for x values. Okay. So looking at this, I feel like we can give it a try. 3, 5, 7, 15 and 7, 22. So it's working. So 3x square plus 15x plus 7x plus 35 is equal to 0. First two and the other two we can factorize. I'm just solving a normal quadratic. That will give me x is equal to minus 7 by 3 and minus 5. I'm cutting down few steps, okay? Because quadratic is assume that, yeah, you might be aware how to solve and get this. Now we have got these two x values. We'll go back to the question again. Since we have got only two x values, and it is quite justified also that one x value is over here, other x value is over here, both of them are negative. Minus 5 and minus 4, 7 by 3. Minus 7 by 3 is approximately minus 2.1 or something, okay? So that a coordinate will be minus 5 because a is quite far. So a coordinate will be minus 5 and b coordinate will be minus 7 by 3. For a, the x value is minus 5, comma, we don't know. Okay. And for b, the y value is minus 7 by 3, comma, we have to find. Okay. Looking at the graph, we can say that y coordinate for a is 0. So I'll just write 0 over here. And for finding y coordinate of b, I need to put this minus 7 by 3 in the original function. This is a mistake. Many students place this x value in f dash x. They just try to find something where you can put x. Okay, it is not like that. You need to be logically clear that why you are putting this x value and where you should put that. So this minus 7 by 3 lies on the curve. So corresponding to that value, if you want y value, then it should be substituted in the curve only, in the function only. So that's why minus 7 by 3 will be substituted here and you can solve and get the answer. Right now, it's not required. Okay. So this was all about how we find maxima and minima. Okay.
Wait, did you skip a couple of steps to find out which value is A and which value is B? Because we need to do the double derivative and plug in the
Ah,
x values, and then we know which one is which, right?
correct, correct. Your question is very valid, but that have no relevance when they give the graph. So it depends on
Okay.
the question. Okay. Over here, graph was
Uh,
given. So looking at the graph and using our common sense, I just decided that minus 5 and minus 7 by 3
yeah, yeah.
should
Okay,
be.
that makes sense.
Okay. Let's say if we don't have the graph and if we want to go conventionally with the technique what we have learned till like right now. Okay. Let us go forward. I will solve further. I will find double dash x, f double dash x, and then we will put these x values and check whether it is correct or not.
Yes. And then whichever one is greater than zero, that one will be the minimum. Lesser than
Yeah.
zero will be the maximum.
So f double dash x will be 6x plus 22. There were two stationary points we were getting, minus 5 and minus 7 by 3. Okay, I have to just substitute both of them over here. So when I put minus 5, then 6 times minus 5 plus 22 is minus 30 plus 22. It is minus 8, which is less than 0. It means x is equal to minus 5 is a point of maximum. Okay. And then when I say a maximum, there is a term, we call it as local maximum. Why local? Because this is not the absolute maximum value. You can see that this curve is going away over here. So it can have more maximum values. But then as per the turning point, this is the local maximum. Okay, and as per the turning point, the other one will become local minimum. So we can check the other point also. F double dash of minus 7 by 3. So 6 times minus 7 by 3 plus 22. It will be minus 14 plus 22, and this is 8, which is positive. Positive means x is equal to minus 7 by 3 is a point of minimum, or minimum means local minimum. Okay, so this is how it is done when graph is not given. This step is absolutely not required for the current question. Like it is just relevant for the question where they have given the graph. If this graph was a part of solution, then we will assume that yeah, graph is not given. But I can see that it is given in the question only. Okay, so this is how we apply this thing. Okay, this flow chart is very important. You should be clear with each and every step which is written over here.